Hello, welcome back. 9.5 constructions. I'm here with my handy dandy homemade document camera so I can show you the constructions. We're going to be constructing a square, a regular hexagon, and a regular octagon today. First up is how to construct a square. Most of you guys could probably figure out how to construct a square without me. You know how to construct a 90-degree angle. You're going to need that perpendicular bisector. You could probably come up with a way to make a square. In fact, it'd probably be a good thing to pause this video now and give it a try yourself before I even show you. However, if you want, there is a particular slick way to make a square. And so while there are numerous ways to make a square, one particularly slick way to do it involves simply creating a perpendicular line inside of a circle. So that's the way I'm going to make my square. Okay, if I wanted to construct a square, I would definitely have to start with my perpendicular bisector construction. So perpendicular bisector again, we've been doing this forever, should hopefully be able to do it without a problem. I'm going to make the whole arcs. I like the way it looks when you do it that way. All right, so there's a 90-degree angle. And what I'm going to do with that 90-degree angle is I'm actually just going to create a circle around it. All right, so there we've got a 90-degree angle with a circle. Now, the reason this is such a slick way to make a square is if I connect those points and I connect those points, that is an angle inscribed in a semicircle, which I believe we've learned before is a 90-degree angle. Connect to those ones. That is also an angle inscribed in a semicircle. So it's 90. And those ones, those are 90. And these are hypotenuses of all equal triangles. Those triangles are all congruent. So there we go, a square. All right, next up, how to construct a hexagon. I've got a handy hint for that one as well. Here we have a hexagon that is inscribed within a circle. But we got a question here. What kind of triangles are formed here? So when I put a hexagon inside of a circle, what kind of triangles are they? If that's a regular hexagon. Well, in a regular hexagon, these angles are 120. So that means each one of those angles is 60. That's 60. That's 60 as well, which makes a total of 60 for each. That's an equilateral triangle. Since that's an equilateral triangle, this length is the same as that length, which is the same as this. So the radius of the circle is the exact same length as that edge of the hexagon. We're going to use that fact to help construct a hexagon. All right, so to create a regular hexagon, I'm actually going to start with a circle. I'm going to be careful not to change the size of my compass I just made the circle in, because I just made that circle of a specific radius. So I'm going to take that radius, I'm going to go on the edge of my circle, and I'm just going to make a mark on my circle. And then I'm going to go to that mark and make another mark, and go to that mark and make another mark. And I'm going to work my way all around the circle, making sure the lengths of between these marks are the same as the length of the radius of my circle. And if I do that, I should have the same picture I had before. And this last one should be, look at that, the same distance apart. Which means once I made all those marks, just connect them up where they intersect the circle. There's 1, 2, 3, 4, 5, 6 sides of equal length. Regular hexagon. All there is to it. All right. The last construction we're going to talk about today is constructing a regular octagon. The hint here is we're going to start it just like we did the square. But then once we make that square, we're going to have found 4 of the 8 points. And then we're going to talk about what construction we can use to find the locations of the remaining 4 points. So I have 8 points total for a regular octagon. Okay, so here I have the square that I constructed earlier. If you want to remember how to make that square, just rewind a little bit. You can watch me make that square all over again. But if I wanted to make a regular octagon, 4 points isn't going to be enough. I'm going to need 8 points. But those other 4 points should be exactly halfway along this arc. Well, if I know that's a 90 degree, halfway is going to be a 45 degree. I need an angle bisector. So I'm going to take this angle. I'm going to do an angle bisector. I could use an arc, but hey, there's an arc already right there. So first part of an angle bisector is creating an arc on the angle, but there is an arc already on the angle. Second part is to take your compass, make it a little bit bigger. I like it bigger for accuracy. Put a slash mark on one side, slash mark on the other side. And that is an angle bisector. It's going to cut that angle exactly in half. If I draw this whole line, it would be the angle bisector. I really don't need the whole line. I just need to know where that angle bisector is going to intersect my circle. It's going to intersect right there. I can do the same thing on this side. Slash mark, slash mark. Cuts my angle in half. Right there. I care where it's going to hit the circle, so I'm going to put a mark there. Same for the other 2 angles. So this 90 degree angle right there is what I'm bisecting. Use my straight edge from that point to the vertex of my angle. There's a point I care about, halfway. And then the last one, let's bisect this angle. Way. So I had a square here, but if I didn't put those marks, instead I could take that. I could go from the vertex of this square to that halfway point, and then back to the vertex. Oops. Halfway point. Back to the vertex. Halfway point. Back to the vertex. Halfway point. Back to the vertex. There is a regular octagon. That's it. End of the videos. See you guys later.